Hi guys, this is Danica. Jordan is not going to be joining us for this video. He's working on homework for problem, so go check that out. This is for Engi 460 Monte Carlo class, and we're going to be doing problem 3 out of section 1.5 in our textbook. So here's the problem prompt. It says a machine tool is to be scrapped 4 years from now. The machine contains a part that has just been replaced. It has a life distribution with a time to failure density of f of x equals x e to the negative x on support from 0 to infinity. Management must decide upon one of two maintenance strategies. The first is to replace the part whenever it fails until the scrapping time. The second strategy is to replace failures during the first 2 years and then to make a preventative replacement 2 years from now. Following the preventative replacement, the part is replaced on failures occurring during the second half of the 4-year span. And then it tells us about some assumptions and that we should simulate 5,000 times. So to help us better understand the problem prompt, the first option that management has is to just replace the machine anytime it fails for the first 4 years. The second option is to break those 4 years in half. So for the first 2 years, they're going to replace upon failure, and during the second 2 years, they're going to replace on failure, but at the 2-year mark, they're going to do preventative maintenance. So to simulate this, we have to come up with kind of like a cost equation. So we're going to say that V is the average number of failures during those 4 years, or for the second scenario, during the first 2 years and then the second 2 years. CF is the cost for replacing the failed machine, and CP is the cost for preventative maintenance. So for the first option that maintenance has, the total cost is just going to be the average number of failures during the 4 years times the cost for replacing each failed machine. The second one is a little more complicated. It's the average cost, or it's the average number of failures during those 4 years times that replacing cost, but then you also have the additional cost of preventative maintenance. So we set those two equations equal to each other, and we end up getting this ratio, and then we're going to simulate in Monte Carlo to find V1 and V2. Now for failures, we were told to use the exponential equation, and this is pretty common for any type of machine failures. If we take the integral of that, we get e to the negative x. We set that equal to r, and then we want to solve for x, so we do a little bit of algebra here, and we end up with x equaling negative ln times, or negative ln of r1 times r2. This is our pseudocode for MATLAB for both the policies. They're very similar. We'll start with policy 1 over here, the failure for 4 years. So we start with y equaling 0 and while y is less than 4. And we go through over and over and over again until y is greater than 4, and we break this loop. And then NF, you're adding 1 every time. It's like a counter. And then your mean at the very end is going to be that V1, which is the average number of failures, and we iterate this 5,000 times. For policy number 2, you're going to do the same thing, but y is less than 2. And then you can iterate 5,000 times and then just double it at the end, or you can iterate 10,000 times. It doesn't really matter. At the end of this, when we put it in MATLAB, it ends up being, when you plug V1 and V2 into the equations, CP, the cost of preventative maintenance, is about 1/5 the cost of the failure cost. So given certain circumstances, depending on how much that cost is and how much the average failure is, you can decide if policy 1 or policy 2 is better. Thanks for watching, guys. Hope this was helpful. And let me know if you have any questions in the comments below.